Okay, so I'm going to do everything from the Unix command line. That's where we primarily do our coding, especially if you do any kind of supercomputing. You're going to do it on a Linux machine. So there are GUIs that can do some of the features or manage your version control system. I prefer to just know how to do it from the command line. That way, if you're logged in remotely to a supercomputer or something where you may not have a desktop or any kind of X Windows system that you can visualize anything with, at least you know some basic commands on the command line. Okay, so the nice thing about Git, so I'm going to assume you have Git installed. It should be installed on every Mac and in every Linux machine by default. It's probably an old version. Of course, if you can use a package manager to update it. So on a Mac, I would recommend Homebrew. On a Linux machine, use, like if you're on Ubuntu, you'd use apt-get, or if you're on Fedora or one of those machines, you would use yum, right, to update. So it'd be like yum install git, or if you're on a Linux, if you're on Ubuntu, it would be apt-get install git, right? And on a Mac, if you have Homebrew installed, it would be brew install git. And if I hit enter, it'll say that I already have Git 2.5.3 installed, so that's the latest version. Okay, so this is basically an empty folder. There's some, I may do some writing in a little bit, and that's what that nonsense about. But let's create an empty folder that's going to be like our source code repository. Okay, so we're going to make a directory source. Okay, so if I go into that directory, it's an empty folder right now. Okay, and I'm going to create a folder. I'm going to create a file, and the file will just be a README, and probably be the only file I actually ever create. But we'll just treat this README file like it's source code. So this is my nice source code repository. All right. So I'm going to write that file, and if we cat, you can see what's in it. So this is my nice source code repository. So now we have a source code repository, and we want to begin to put things into it. We want to begin to version our software, right? And by the way, what motivated this is all my students, these guys up here on the front, they all come to me with a version of their code, and it's like got a date on the end of it, or V1234, it's got some ridiculous versioning scheme, and you look in their folder, and there's 100 files in there, and you can't find anything, and it's awful, right? So Git is so easy to create a repository. All we have to do is type git init, and we have initialized an empty Git repo under this. So now we have a repository created, okay, but there's nothing in it yet. We have to add things to it, right? So we have a file in the folder. I want to add that file to the repo, so I'm going to type git add readme, okay? And now if I type git status, you'll see that in green here it says that there's a new file, right? So these are changes to be committed. So I haven't actually made a commit or a snapshot in time yet, okay? So I can, this file here, because it's in green and because I added it, it's staged. This is what's called staged. It's staged to be committed, okay? So we'll go ahead and commit it, and with that, I'll type git commit. And I won't type anything else. I'll just type git commit, and it'll open my editor, okay? Now my default editor is Vim. If you had your, you can set an environment variable to have it open Emacs or some other favorite editor. My editor is Vim, and so now I can have a commit message. So let's talk about what a commit message should look like. All right, so the standard convention is to have one short line on the top, okay? And so this line will be, initialized repo, right? And so normally you'd have, one short description on the first line, followed by a couple of spaces, then a longer, detailed commit message, right? So this is where you would go ahead and fill in a lot of information. And when you work on a software project, with other people, it's really important to have detailed commit messages. In fact, it's weird. Just yesterday, I work on a software project with about 6 other developers from Sandia, and a new guy came on board, and when he committed, all his commit message says was change files. And it started a long discussion amongst the developers. Everyone was basically bitching at him, and we made him go back and amend his commit message to tell us what he did. Because we have a continuous integration system that actually emails us at every commit, so everyone on the development team gets an email on every commit, and we read those commit messages. I read every one of them. That way I sort of know what's been changed and what goes along. Now this is a development model we use. There's other ways to do it in terms of how you're developing on a team, and I'll give you some ideas about how to do that, about good practices for that too. This works well for us because it's a small team. There's only like 5 or 6 guys. We read all the messages. And so this sort of, we know what's going on, how the code's changing, and what's going on. Yeah.
How about the other methods? Can you remove them?
Yeah, if you want. I think it's a good idea to leave them there because it tells you what files are changed. I know, I actually look at that too. So usually I'll look at the description there, and then I'll look at what files have been changed. So I think it's a good idea to leave them there, but you could certainly get rid of them if you want. So anyway, when I write and quit this file, so there's my, my one-line commit, and then my more detailed commit message. And when I write and quit this, I will then have a commit in the history. Okay, so that's a snapshot in the history. Okay, and so I can type git log, and I can see. So this is the commit. It's a long string there, and we can refer back to this commit later. I'll give you an example of how to do that. And there's the author and the date, and you always, when you type git log, you'll always at least see the short message, and sometimes there's some commands you can pass, some options you can pass to git log to tell it how much of the information you want. I actually don't know all of those commands. Okay, so then we would go on and make more edits to our file. So this is all right. So now I have, now notice if I type git log, you only see the one commit because I haven't made a second commit. I haven't staged this even. So if I type git status, what you'll see is a red here. That means that this file has been modified. Okay. Now if I added a new file to the repo, so let's say that I'm just going to add a new file, right? Now if I type git log and git status, see that this file is modified, but there's also a new file here. Okay, so it's telling me this is an untracked file. This is saying this file is tracked, meaning you have a version in the repo of this file, but you haven't staged it for a commit yet. If I staged it, it would be green. Okay, I haven't staged it for a commit yet. This is saying this is an untracked file. It's a file that you haven't even added to the repository. Okay, so I can stage that file for commit. I say git add readme. Okay, now if I type git status, you'll see now it's green. That means it's staged for commit. And I'm not gonna add this file to the repo just yet. Okay, so it's just gonna remain there. And now if I type git commit, and now what I can do is before I just hit enter and it brought up an editor. But if I just need to leave say my commit message is short, there's no reason to leave a long detailed one. I can actually put the commit message right on the command line. So I can say git commit added bullet list, right? And so then now I have a second commit, and if you look at the log, there's my 2 commits. So the first one I initialized the repo, the second one I added a bullet list, okay? And then if I type git status, you see that this new file is still there, and I haven't done anything with it, okay? Now let's say a lot of times, yeah.
So if you had added a couple files to the repository, but and you made changes to both, but you only added or did git add that one file from those two,
Yeah.
and did a commit, what would happen to the other change file that was not been added?
Well, if you don't explicitly add it and you don't stick anything on the command line to tell it to add all tracked files, then it would just be left modified but unstaged, or out of the repo, right? So you can make changes to 10 files, but say then you realize for some reason it makes sense to commit changes from 5 of the 10, right? And group them, because so let's say you made changes to 10 files. One of them added feature A and the other one added feature B. Well, it really would make sense to commit those, add feature A, add feature B. Even though you've made all the changes, you can just add the ones you split on a file by file basis, right? Now you can't sort of at that point, if part of feature A was in file 1 and part of feature B was also in file 1, you can't really split that out. But you can, on a file by file basis, you can certainly pick and choose which ones you want to add to the repo at any time, okay? So sometimes you might have files in a directory for one reason or another that you don't want to show up here every time. They could be configuration files or things that maybe you don't want to commit necessarily to the repo, but you want to leave them in the folder for one reason or another. What you can do then, there's a special file in any Git repo. It's a hidden file. So it starts with, if you name a file git ignore. So I'm gonna create a new file. I'm gonna name it git ignore. And if you create that file, then anything you put in here, and I'm gonna put the name of that new file. So I'm gonna put new file in there, right? So if I cat git ignore, you'll see that the name new file is in there. Now when I type git log, new file won't be there because git ignore ignores it, right? So now when I type git log, git status, new file's not there, but the git ignore file is, okay? So let's say I can add that to my repo, so I can say git add git ignore, git commit message add git ignore, all right? Git log. Right? So my initial commit, the commit where I added the bulleted list, and the commit where I added my git ignore file, right? And now if I type git status, nothing to do, no files. Yeah.
So can you put git ignore inside git ignore file?
Yeah, you can actually. You can. Yeah, so that it changes to git ignore won't show up. But I mean, usually I think it's common to add it to the repo and store it, with the repo information. Actually version control the git ignore file. Okay. So let's make one more change to the README. So I'm going to go down here and I'm going to say one more change, right? And now if I type git status, you'll see that this is here and it's modified, okay? Now I could, if I want to stage it for change, what I could do, of course, is git add readme, right? But since it's already tracked, right? This is already tracked in my repo and been modified. I can go right to a commit, so I can say git commit, and what I want to do is I want to put -a. That means commit all changed tracked files, right? So if there's a file in the repo already, and I've made a change to it, commit that file, right? And it would, if there was 100 in there, it would commit all 100 of them, right? Any that had been changed, okay? But that saves me that extra git add step, right? Because I'm just, yeah.
Are you using the word tracked and staged?
No. Tracked means a file is tracked if it's in the repo. If I've ever added it to the repo, then it's a tracked file. Okay? Even if it's 500 commits ago, if I added it to the repo, it's a tracked file. Okay? A staged file is a file that's staged to be committed on the next commit. Okay? And so I can have tracked files that aren't staged, meaning it's tracked. I made a commit 100 commits ago. but this next commit, I'm not going to commit any changes to it, right? Okay. Now this A is going to, again, it's going to commit all tracked files. If you've ever made a commit on the file and you made changes to it now, on this commit, it's going to be committed, okay? And of course, then the M adds the ability to add the message. So last change. And you know, I really should be more descriptive, but I'm really kind of not making very interesting changes here, right? So now, initialize, added the bullet list, added get ignore, last change. Yeah?
So isn't there some kind of tense that you should use when you're writing the Git?
Yeah, you should, yeah, I mean, the common use is to use the present tense.
So
I don't know. Yeah, I don't know. Yeah, so if you look on, you know, a lot of if you look on the web, a lot of the best practices say that you should say, you know, add this instead of added, or, you know, yeah, I don't know why, but yeah, the preference is to use the present tense. Okay. So let's look at what's in, let's cat the README. Okay? This is what's in the README. All right. Now, let's say I don't like this last line, right? I mean, really what we're talking about is source code. So let's say I added some feature and then I decide that, or it breaks, right? So a lot of times what you do is you make incremental commits, right? So you might, you know, in creating some big feature in your source code, it's not often that you'll write 500 lines of code and it's just going to work, right? Normally you're going to write 10 lines of code and commit it, and 10 lines of code and commit it, and 10 lines of code and commit it, and 10 lines of code and commit it, 10 lines of code and commit it, right? And somewhere along the way, you might break the code, something that worked, used to work, won't, and you want to go back in time, okay? And so this is why it's important to have good commit messages so you know where to go back in time to, okay? And so let's say I want to go back in time to, well, let's say I want to go back in time to the original commit, right? So the initial commit is 3B55F33, right? So what I can do is I can say git checkout 3B55F33. And you don't have to type out that whole long string. I mean, I could copy it and paste it. You only have to type out enough letters such that it's unique, which usually only means like the first 5 or 6 letters. Right? So as long as there's no other commit in the repo history with the same first 5 letters, then you're going to get the right one, right? So it gave me a little warning there that I'm in a detached head state. Don't really worry about what that means. I mean, it just really, it's telling me that you're in your master branch, and I only have one branch. We'll talk about branching in a second. You're in a master branch, but you went back in time. And so, you know, you can look around, make experimental changes, commit them. You can discard any commits without impacting any branches. And, you know, but normally what you do when you make changes is you want to create a new branch. And we'll talk about branching in just a second. But the point is, I went back in time, and now if I look at the README, now if you look at the README, all that extra text, the 3 bullet points and the last change line I made, they're gone because I went back in time, okay?
What if you made some changes here and you committed, then you won't be going after the last change because you're detached from the
Yeah, exactly.
making a branch here?
Exactly. So in that case, what you'd want to do, so let me just get back to I'm going to go back to head. Let's see. All right, so now I'm back, and you know I use this little special command line, this thing called power line, and it tells me what branch I'm in right here. So you can also just type git branch. You can type git branch, and it'll be a star next to the branch. So there's only one branch, and it's master. That's the default branch name, always, when you first start. If you can't see on this screen, you can see over there. Okay. So yeah, this is called Powerline. It's a Python script that it's called Powerline-status that I use. Yeah, but you can install it on a Mac or a Linux machine. So yeah, what you normally, if you actually want to make changes to something in the past, right? Normally, then what you'd do is you'd create a branch. So what I'm going to do is I'm going to say git checkout branch, and so this is, I'm going to basically in one command here, I'm going to create a new branch that I'm going to name here and check it out at the same time. So I'm going to call my new branch. Awful name for a new branch, but nevertheless. And now you can see from my power line, I'm in the new branch. I'm in the new branch. And so also I could type git branch. And now you'll see there's two branches, master and new branch, and the star is next to new branch. So that's the branch I'm in. Yeah.
How can you tell what to do branch and
Yeah, it'll be the last commit unless you go back. Unless you go back to a previous commit and branch from there, it'll automatically be the most recent commit. Right? So normally in a branching model, what you would do, and this is really one of the powers of Git, is that, I mean, it's designed so that you should branch frequently. And in fact, when I'm working on source code, what I want to do is I always want my master repo to be a repo that works. So if I'm going to add some new code, or I'm going to do a bug fix, or I'm going to do anything experimental, something I want to try out and maybe see if it works, and then if it doesn't, I just throw it away. I always want to branch first, okay? So, I mean, it makes it so easy to branch. This really should be your model. It should be branch and then make changes and leave your master. Master always passes tests, right? So master should always be the working branch, okay? That it works. Anybody who goes to your master branch and downloads it should be able to compile your code and run it, okay? We can also talk about release branches and tags and all that stuff. Those would be snapshot released branches that you could keep a history of. So if you wanted to go back to a previous release branch, meaning where you released your code and you versioned it 8.37 and you gave it a name, you can also create branches and store those in history. You can also do that with tags. But nevertheless, so then what we do is we'd come into now we're in a new branch, and I'm going to come in here and I'm going to do something experimental, right? Okay. So now I'm in the new branch. I've done something experimental, and it works. Okay. So now my new feature has been added. It works. I'm going to go back to my master branch. So I'm going to say git checkout master. Okay. And then I'm going to say git merge. I can never remember if it's master new branch or the other way around. Git merge new branch master. Oh, you know what? What did I forget to do? I forgot to make a commit. So it's telling me it's up to date. I'm trying to merge something, but I didn't make a new commit, right? So I need to go back to new branch, make a commit now. So I can say git commit experimental change now working. Okay. Maybe it didn't like my exclamation point, but okay. So now go back to master and git merge master new branch. Okay. Now if I look at what's in README now, something experimental is there, but I'm in the master branch. So it merged the two. And Git's smart enough such that if master and new branch have no conflicts, So in this case, the only difference is it was a different line, right? But let's say I actually changed something that conflicted with master. Then get smart enough that it's going to actually notify me that there's a merge conflict. So if there's no conflict, it's just going to merge the files. The two will become one, okay? But if there is a conflict, then it's going to be smart enough to notify me, right? So let's do that. Let's purposely make a conflict. So, okay, so what I'm going to do is in master, I'm going to change the word change. I'm going to change it to master. And I'm going to commit it. Then I'm going to switch my branches. So I'm going to go back to new branch. And there I'm going to go look at README. And now here I'm going to change to new branch. Right? So on master I changed it to master. On new branch I changed it to new branch. I'm going to make the commit. And I'm going to go back to master. Now I'm going to try to merge. Conflict. Merge conflicts in README. Automatic merge failed. Fix the merge, fix the thing, and fix the conflicts and commit the result. All right. So what I'm going to do, I'm going to look at README, and it's smart enough that it tells me. So it's saying, on head here, this is what you have. On the other branch, this is what you have. Fix the one, pick the one you want. Right. Now it's not often that you, well, sometimes you do this on accident. Usually, over short time periods, you wouldn't even do this on your own. As you know what you wrote in one branch and you know what you wrote in another branch, and it's therefore not likely that you're going to make changes in both of them at the same time and try to merge them. You know that's going to be a conflict. Where this arises more often is when you're working on a development team and you're trying to merge changes from two different developers, right? So one guy's working on part of the code and he makes some changes at the same time another guy's working on a similar part of the code and he makes some changes, and then you try to merge them, and if they came from the same common commit history, then Git's going to say, well, wait a minute, you made two changes from the same commit, now you need to fix this, right? So all we have to do is fix it, right? Just pick the one we want and commit it. So now my history's gotten so long that it won't fit on one screen, but it's fix the merge conflict. It shows the commit here that I made on new branch. It shows the commit I made on master, and then the other stuff. And I can actually scroll on down. So it actually opened this up like in a little editor. I can hit clear. Okay. Yeah. I mean, normally this would happen if from a common commit, two branches that you're trying to merge made changes to the same line of code, right? Yeah, and again, most of the time when this happens, it's in a team environment where multiple developers are working on the code at once.
So if you're working by yourself, you should be only operating off of one branch at a time?
No, not necessarily. A lot of times what we do, again, if you work on the model that master always works, a lot of times what you want to do is you got some big idea, it's going to take you 3 weeks to implement some new feature. So you branch and you start working on it. And along the way, you commit and you commit and you commit and you commit and you commit. And then you get an email from your user who's using your code and he says, I found a bug. And the bug fix is only going to take you 30 seconds. So what you do is you branch off a master, bug fix branch, right? Get in there, 30 seconds, you commit it, you merge that back into master, okay? And so now master's moved ahead. Your feature branch, your big feature branch, you're still working on. And at that point, you can do you can merge the bug fix into your feature branch so that the bug fix is in your feature branch, and you can keep going from there. Or you can, if it's not important to your feature branch, you can just keep working, and then later, when your feature branch is done, you can merge it back into your master. And I mean, that brings up another point. So let's say I have git branch, and I'm going to delete that new branch. Okay, so that's the command. So usually this is what you do. You rapidly create a branch, make your changes, and once they're merged, then you delete it, right? Because you don't need it anymore. Okay. So now I'm back to, if I just type git branch, I'm just back to master. Okay. So let's say I have big new feature branch, right? So git checkout branch new feature, right? And so in my new feature branch, okay, a lot of times we work incrementally, right? So I'm going to go in here, I'm going to say git readme hack commit new feature commit 1, okay, and then I'm going to hack new feature commit 2, and then I'm going to hack, right? New feature commit 3, okay, and then hack, and then I'm going to say, okay, git commit new feature implemented. Okay, so this is often what we do, right? Big new feature is going to take you 3 weeks to work on. You of course want to save all those incremental commits, right? So you hack, committing along the way, and we can go back in time. You can change your work, whatever you want to do. But eventually, you get to the point where it works, and now I want to merge it. Now, do I really need all of those little incremental commits, the little hack commits? You know, when I merge it back, do I really need all that? Or do I just want one commit that says, I changed, I added this great feature, right? That's more likely what you want, okay? So what you can do then is you can say, so I'm going to go back to master, git checkout master, and git merge squash master new feature. Didn't spell squash right. Squash. Okay. And so now if I look at git log, I have to now, so it brought everything over, but I do have to commit it with a commit message. So I'll give it a commit message. So there's all the squash. So see, it automatically populated this. So it says squash commit of the following, new feature commit 1, 2, 3, new feature implemented, right? And you can leave that stuff if you want, and it'll show up later. And you can just say, you can give it a commit message. So new great feature merge to master. And you can leave that stuff down there, or you could get rid of it if you want. If you want a nice, if you just wanted to write a nice explanation that, this is a merged commit of the 50 commits I made over on my big new feature branch, right? So then once I do that, new great feature merge to master. Now it'll show up in the git log, right? So you see it says new great feature. That's the commit message, and it said squash commit of the following. Well, the following's cut off, But again, if I pass some extra variables to git log, it would show me the complete commit history, which would include all that information on all those squash commits. So this is a use case, right, that happens a lot. We have some big feature that we branch and commit, and then we want to merge it, but we want to do a squash merge.
Will you be able to merge the new branch and the master branch from them while you're still in the new branch, or do you have to go back to the master branch?
No, you can do it. You can do it from the other one. I think the order is reversed. If you look at what the syntax is for git merge, let's see. Well, I might have to Google that, but I think you can do it. Just you put the order reverse instead of. I always if you go to the branch you want to merge into, then it's always that branch and the other one. Right? So that's why I remember it. So I always do it that way. Because usually it's more natural to do it that way anyway. Because usually after your merge, you just want to delete the old branch. Right? Once you're if you're using this sort of, so then I go in git branch, and I can just git branch, delete, new feature. Oh, it's telling me it's not fully merged. Not sure why, but if I wanted to, I could look into that. Otherwise, I can just get rid of it. Okay, it's not really important. All right, so that, even some of that is probably more advanced for your day-to-day use. I mean, normally, yeah.
So if you add a new line in the middle of the code, is it smart enough to figure it out that you are merging, or if you add a totally new line in the middle of the code?
It'll figure it out. It'll just stick it in there. Yeah. If there's no conflict, it'll just merge. Yeah. And this is actually a good reason. I write papers with students in LaTeX, and there's been many times where I'll be editing the first paragraph and the student will be editing the 8th paragraph at the same time. And then when we commit them back to the master repo, they just goes in and just don't even worry about it. So this is only, this is all local, right? I mean, I did everything here on my Mac, right? Normally, when you work on real software, a big software repository, you work on it with a team of people, and you have a central repository, right? So somewhere in the sky, right? Somewhere in the cloud, you're going to have a central repository, or on a server somewhere. It doesn't have necessarily have to be in the cloud. It could be, on Stampede, right? You could have a central repository that multiple people are going to develop from, okay? Well, nowadays, I mean, it's basically ubiquitous that people use GitHub, okay? So GitHub is sort of the Facebook for coders, right? I mean, it's the cloud. It's a cloud-based repository hosting service, and of course, if I look up Linux, who writes Linux? Minus Torvald. There's the Linux kernel. If it's good enough for Linux, it's good enough for me, right? By the way, who wrote Git? Same guy, Linus Torvald. Same guy who wrote Linux. He wrote it to help manage Git, because before Git, and it's not completely true, there were other distributed version control systems, but most of the time people used what are called, I don't know what they're called, not distributed version control systems, most notably CVS or SVN. And these are very sort of linear in the sense that they're centralized, right? Whereas Git is decentralized in the sense that I can have one master repository, okay? And developer A and developer B can clone from it. And when they clone from it, they get the entire repositories, okay? So developer A and developer B can both clone, and they can have the entire repository histories. And then developer A and developer B can go on making changes, and at some point, developer B may call developer A and he says, you know what? I need your help. I have new feature and I can't fix it. Can you take a look at it? Well, the old way would be you'd have to go back to the central repository. If you use SVN or CVS, developer B would have to check in code into the central repository so that developer A could check it out. And this is particularly bad if that code doesn't work. I mean, why do you want to check in code that doesn't work and keep a history of broken code into the central repository, right? But with Git, developer A can clone directly from developer B. They share a common history in the cloud or the master repository. But now developer A can get directly from developer B, can go on and make changes, can either then push those changes back to developer B or push them back to the master repository. Okay? Now imagine this little triangle I drew, but now there's 10,000 developers. And that's what you get when you get Linux, right? I mean, if you look, it's not 10,000, there's 5,400 people who've contributed to Linux. And in reality, it's probably a lot more than that. Those are people that have issued pull requests directly to the repository. I mean, in reality, there's probably another 100,000 people that have found some little bug and sent a file attached to an email directly to Linus, and he fixed it. Right? So anyway, you don't have to use GitHub, okay? There are other tools, Bitbucket and GitLab are other ones that do very, very similar things. Mostly the pricing structure is what makes them different. GitHub is free for an infinite number of public repositories, meaning the public repository meaning anybody can go and see your source code. Right? Now you can license, yeah.
Here's the big bucket for UT students is unlimited and has a limited number of private repositories.
Yeah, I think also GitHub, yeah, so that's true. So Bitbucket is very, very similar to GitHub. They have some of the same features. Their pricing structure is based on the size of the development team. So at Bitbucket, you can have public and private repositories, but your development team can only be up to 5 people. If you want to have more than 5 people, you have to pay. Okay? GitHub, you can have unlimited public repositories, unlimited development teams on those public repositories. Okay? Their pricing structure comes from private repositories. So depending upon how many private repositories you want to have, that is what you have to pay, right? So like for 5 private repositories, it's like $7 a month or something like that, okay? But I think as a student, you can actually also get on both Bitbucket and GitHub. They have student. If you write to them, they'll give you their sort of lowest package for free. And I think on GitHub that means you can have 5 private repositories. On Bitbucket it means you can have a team of 10 developers or something like that, right? But yeah, so they're very, very similar. I actually have accounts on both, but most of the time I use GitHub because that's where most of the people would go first, you know, or you're going to Google something GitHub, right? And so, you know, so if you go back to me, you know, here's a bunch of repositories that I have up on GitHub. If you've ever had a class from me, you might, you know, I actually have the source code for the websites that I use in the class. I have the source code for the websites stored there, and I also actually host the websites on GitHub. So GitHub has this nice feature called GitHub Pages. All you have to do is create a separate branch. So just like we've had the master branch and we created these new feature branches, if you create a branch called GH-Pages, and you can then push HTML files to there, GitHub will automatically render them. So like if you go here to this page, on the GitHub branches page, this is automatically rendered if you know the site. Well, the site is the repo. The site is my name .github.io, in the repo, and so that's rendered on their server, free. So anyway, that's just another nice little slick feature. Okay, so let's say we want to now we're going to work on this code that we've been working on in class, my README code. We're going to work on it with a team of people. So we want to put it up in the sky. We want to put it on GitHub, right? So the first thing we have to do is create a new repository. So if you have a GitHub account, you just go into yours and you type new, and then we can say, let's see, what do you want to call it? Git tutorial, okay, and repo from tutorial. Right? We'll make it a public one, and you could initialize it with a README. We already have a README in there, so we don't need to do that. We're just going to create the repository, all right? And so it gives you some commands here. It says, or push an existing repository from the command line. Well, I have an existing repository. It's the one we've been working on. So what I need to do is I need to add a remote. So I'm going to use this command, git remote add origin. Okay, origin is sort of the default name for the remote location. Okay, I could actually name it anything. I could replace origin with GitHub if I want. But the sort of default that everyone uses for the cloud central repository is origin. Right, so I'm going to say git remote, and then I'll have this string here, which is the link, and then I push that up. Okay, so the first thing I'll do is add the remote. This adds that location to my repository. Okay, and then I'm going to type git push origin master. Right, and so again, git push means push it to the cloud. The cloud being origin, the branch being master. Okay, and you can set this up to where you don't have to put your password in, but it doesn't hurt to do it that way either. It just depends on if you want to use SSH or HTTPS. Okay. Okay. So you can push the whole thing. If you had multiple branches, you could push the whole thing. There's another command you have to add, another option you have to add on the command line. I'm not sure. Okay, but if I refresh this page now, there's my README and my gitignore file in my repo. One cool thing about READMEs is that they're rendered, right? So the text is actually rendered. And the reason I put the file extension there, MD, is because it's in Markdown. So that's why I have that bulleted list that actually renders it as a bulleted list. And you could have equations in here, other things, whatever you want, right? Okay. So now this is really just a mirror image backup of what we did locally. Okay? Now, what you would normally do then, so now let's start to talk about common use case in a team environment. Okay? So in a team environment, what you normally do is you'd have one central master repository. Okay? And you could set up organizations on GitHub, so you might set up an organization named after your code or something like that, and you'd have your one central repository. I guess before we do that, let's just, you probably may already know this, but I can now clone this, right? So I'm going to go to a different location. So I'm going to go to like my desktop, right? So clearly on my desktop I just have this blank and some PDF file, right? So now I can clone that repo here, and it's not that useful to clone it onto my computer in a different location. Where you normally do this is maybe you're on TAC, right? Maybe you log into Stampede and you want to clone the repo there. In fact, let's do that. So let's SSH, if I can remember my login. Is it JT? It's JT? All right, so now I'm in my home directory on TAC. It doesn't like the SSH, so let's switch to HTTPS, right? And I can type git clone. Right, so there my Git tutorial is. Right, there's my README. And I can go in here and I can make changes to it. Like, let's see if I can add some equations. Can't remember if it will render equations or not. Okay. All right, so then get status will tell me that I've modified README. So remember, I'm on, even though I'm standing here, now I'm logged in at TAC, and I'm making these changes physically at TAC, right, in that same repo. So then I would get commit, removed, hack. I'm sorry. I forgot my AM, right? So AM. All right, and it wants me to put some git config stuff. I think I can skip that, but now if I push it back to origin master, I wonder. Well, maybe it may be that TAC has the port blocked or something. I'm not real sure. But not real sure why that is, but I should be able to push the change back. Right? So TAC may have it blocked. I thought I'd pushed changes from TAC before, but anyway, theoretically that should work, right? And I can make changes anywhere, push them back. Okay. All right. So back to the sort of idea of the team environment idea. Okay. So you have a master repository. We'll use this one as an example. What you would normally do as a team member is you would come in here and create a fork, okay? So now I come in and I'm going to fork this guy. Well, it doesn't make sense to fork it as myself, right? So I'm going to fork it as, you know, I have this organization, PGE, whatever, right? So I'm going to fork it there. It'll take a few seconds. So now it says this John T. Foster-pge.utexas and Git tutorial, right? So this is, and it says right there, forked from John T. Foster Git tutorial. Okay? So normally then what the workflow would be that I would come over here, okay? I'm going to get off attack. I'm going to clone this forked repository, right? The forked one. I'm going to clone it to my desktop, and I'm going to go in. I'll make the changes. See if I can get it to work. So I make the changes, and I'm going to push back to master, origin master. Okay. Okay. Now, sure why it didn't render. But anyway, I made some changes, right? Now notice this is in the organizational account, the one I forked, right? So if I go back to the original one, those changes aren't there. It's what it was, okay? So it's a little awkward because I'm like, I forked my own repository and I'm sort of committing to my own repository. But what I would normally do here then is if I would go back to the previous one, okay, what I can then do is I can submit a pull request. So I'm going to open a new pull request, and the pull request, you'll see it's going to be automatically, it's going to be the last commit. So the last commit, it'll show you what I changed, right? So it said subtract, hack, 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 subtract, 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 add those 3 lines. And you can't really see because the colors are washed out, but when I'm looking at it on my screen, these are green and those are red. So it's saying delete that, add that. So I can, one little visual, I can see exactly what was changed, okay? And yeah.
So what's the difference between forking and branch?
So a fork is sort of, at least initially, it's an exact mirror of an entire repository, which could include branches. Right? So I could have master and new feature and new feature. And if I forked it, it would copy everything. Right? And then in my fork branch, I can then go on and create even more my forked repository. I can go on creating new branches and everything else. And ultimately, what I want to do is I want to submit a pull request back. If I want to get my changes back to the master repository, then I want to submit a pull request. And so that's sort of what we're doing here. Okay. And so clone just means take it. So a fork happens in the cloud, right? On GitHub, on Bitbucket, whatever. A clone means take it from the cloud locally, make a copy, or even locally to locally or whatever. Right? So clone is the command you'd use if you're getting it from the cloud, if you're getting it from your your friend's repository, whatever. It would be on the command line. The fork happens in the cloud, okay? So once I create this pull request, it gives you an option to put in some comments, right? And I'm going to create the pull request. And so then what happened? That's weird. We're still on, I think, right? Weird. Okay. Well, I was almost done anyway. I mean, basically, then the idea would be that I could go in and I can merge that pull request. And there's a web interface, so I'm looking at a screen right here, which would allow me to just hit merge the pull request. And now that change would propagate into the original forked repo. Okay. Now there's a reason for this pull request nonsense because you could ultimately, we could have a master repository, and we can add permissions such that we can all commit directly to it. So you might ask, well, why would I ever do this fork pull request stuff? Because I have permission to commit right to the repo. I mean, I could just push right to it. I don't need to do this pull request stuff. But the benefit of doing this is the best use case sort of workflow type best practice thing. The benefit is, even if it's your, say you have 5 developers and it's your pull request, even though you have permission, I was about to have permission to approve my own pull request, right? Even though you have this, one benefit as working as a team, if you'll submit pull requests and if you'll maintain a master repository and you'll submit pull requests and ask your teammates to review your code. And so you can set up a policy within your development team that someone else is going to, you can't approve your own pull requests. Now, I don't think in GitHub you can't stop that. I mean, if you have permissions to do it, you can do it, right? But you could just set up a sort of rule of thumb within your own team that says someone else has to approve your pull request. And what that does is it allows you to go in and you begin to see how other people write. And for one, you get eyes on other code. And what it'll automatically do over time is it'll standardize the code base in some way, because you'll see how other people code, and you'll sort of so it'll happen organically that you'll sort of come to one best practice way to code. It just happens. And then that makes the entire code base easier to read because you're all following some kind of standard, right? Even if it's one you made up yourself. And so that's one advantage to doing that. Otherwise, it's also just you get another set of eyes on your code. Maybe someone else can see, oh, maybe you should have done this a better way or whatever, okay? And of course, you can always, if it's a bug and you need it in there right now, and it's a serious thing and you don't want anyone else to have your code unless you fix it, by all means, approve your own pull request and go on, But that's one advantage. I thought we'd be done and I'd have time to even talk about other stuff. But another cool thing about GitHub is it integrates really nicely. And if you guys are interested, maybe we can just do another session on it, on continuous integration, okay? How many of you write serious software you think is serious? Like, no one? No one writes serious software? Yeah. Do you have a test suite for your software? Meaning, for basically every function you write, do you have a test that tests the functionality? All right. Well, your code's not serious then. Right? 99% of code written in academia is not serious. And you should learn to use unit tests and test suite frameworks. And if you're interested, maybe we could have a whole discussion on that. But like the codes that we write and I develop in, they are thoroughly tested. Right? So basically, every function in the code has a test that pushes its input arguments to their edge cases, tries to make that function fail and fail gracefully, and tests how it fails. Okay, and we also have those are called unit tests. We also have regression tests, which essentially test the functionality of the code and make sure that the entire code, when you run a simulation, you get the result you used to get. Right? You don't want to go on adding features and breaking old things. Right? Those are called regression tests. And then we also have a suite of verification tests. In verification tests, you're actually verifying against some known analytic solution or something. So you have a simulation code that produces a result, and you want to compare it against some known solution that either it's analytic or maybe maybe it's just such a small problem. It's like 4 nodes or something, and you calculated it by hand, and you know the exact answer, right? So those would be verification tests. We also have tests for performance, how fast the code runs. And all of these things are in a test suite, a test harness, so that they can be run automatically, okay? And one nice thing about GitHub is it integrates with several continuous integration platforms, most notably one called Travis-CI, such that upon every commit, Travis is monitoring your repo, and Travis is another cloud-based service. Travis can monitor your repo, see that there was a commit, automatically pull your tests over and run them, and give you a report and tell you if it tests or not. So ideally, you should run all your tests before you make the commit, but sometimes we get lazy or we forget. And this is why I don't think any code without tests is not serious, because so many times in my life, I made the smallest, most benign change to my code, and I thought, oh, there's no way this little change broke anything. I'm just going to commit it. Well, we have continuous integration, so it doesn't matter if I run the tests or not, they're going to get run. I'll make a commit, and 5 minutes later, I'm getting emails. You broke the test, you broke the test, you broke the test. And this has happened to me 1,000 times. And so I'm telling you, if you don't have tests in your code, you have buggy code, and you don't have serious code. And you're not alone if you have this. 99% of all academic code is like this. But you should learn to write good code, learn to write tests, and your code will be a lot better off for that. So, if you guys are interested, we could maybe do this whole thing again, just talk about testing and continuous integration. Because you can automate that. Nobody would do it if it was hard, right? Because it's bad enough that to write the code and all that. But they have unit test frameworks that make it really easy to write the tests. And then, of course, now you have these continuous integration services to make automation of it, automatic, right? And I've even hacked. If you look at my blog post, there's the first one. I've even hacked like my CV. So, if I give a new talk or add something to my CV, I keep it in a Git repository, and I just, I add, say I publish a new paper, I just add the paper to the CV and I hit Git push. It goes to GitHub. Travis sees that there was a change, pulls it over, rebuilds my web page, and rebuilds a compiled PDF because it's a LaTeX document, and pushes it back to the repo. And it just happens automatically. So all I have to do is make the change and hit git push, and 10 minutes later I have an updated web page and an updated CV. And it just happens, via Travis automatically.